When you learned about perpendicular bisectors, there was a special property where if you take the three perpendicular bisectors in a triangle, the point of intersection of all three is called the circumcenter. And I had said that the circumcenter would be important for finding the center of a circle. And before we can get to that, I want to go over one key word, and that key word is a chord. The chord of a circle is created between 2 points on the circumference of the circle. So if you look at the diagram, you have 2 points here on your circle, and if you connect those 2 points, that is a chord. Down here, that's another chord. Now if you take and you determine the perpendicular bisector of any two chords on a circle, the point of intersection of these perpendicular bisectors will be the circumcenter, and the circumcenter is actually the center of the circle. So, to find the center of a circle, you find two perpendicular bisectors of two chords, and then find the point of intersection. And when you think about point of intersection, you should be going back to linear systems and solving by substitution or elimination. So let's go ahead and try this out. So a circle has the points negative 1, 2, 3, 6, 9, 0. Determine the circle center. So let's go ahead and plot these points. Here is C. D is at 3, 6. And 9, 0 for E. Now if you connect your dots to create a circle, here is our circle and we are trying to find the center of it. So step 1, I'm just going to draw what my chords would look like, and I don't care about the equation of these chords, but I just want to draw them in for reference. So I'm going to look at chord CD and chord DE. Now you could have chosen any combination, so technically CE, that would also be a chord that you could use. But these are the two chords I'm trying to find, which means I'm going to find the perpendicular bisector of CD and the perpendicular bisector of DE. So roughly, I'm just going to do a refresher on what a perpendicular bisector is and sketch it. It's not going to be accurate at all. I am just doing this for the diagram. So we know a perpendicular bisector, the word bisector means cut in half. So if I'm looking at CD, I'm going to need a midpoint. And same with DE. That way I deal with the bisector part. Now perpendicular, my line has to be perpendicular to these two chords. So for CD, my perpendicular bisector might look something like this. And for DE, my perpendicular bisector might look something like this. So my center should be somewhere there. Now again, this is just a sketch to guide my steps. So let's go ahead and look at the perpendicular bisector of CD. So I first plotted a midpoint, so maybe we'll find the midpoint first. You can find the slope first, it really doesn't matter. So I'm going to make sure I look at C and D. So I'm going to add my x's and divide by 2, add my y's, divide by 2, and my midpoint will be 2 over 2, which is 1, and 8 over 2, which is 4. So there's that midpoint. Now let's go ahead and find a slope. And once I find the slope of CD, I can take the negative reciprocal to find my perpendicular slope. So make sure you put your y's on top. So 6 minus 2 over 3 minus negative 1. And if I clean this up, I'll have 4 over 4, which is just 1. And now if I want my perpendicular slope, don't forget your good notation here, the negative reciprocal of 1, which is 1 over 1, will be negative 1 over 1. So just negative 1. So now I can find the equation of this line using my slope and my midpoint. So let's go ahead and do that. So we have y equals negative 1x plus b. Let's sub our midpoint in. So for y I will put 4, and for x I will put 1. And now I can do my multiplication. Negative 1 times 1 is negative 1. And when we bring that negative 1 over, it will turn positive, and 4 plus 1 is 5. So there we are. So the equation of our first perpendicular bisector is y equals negative x plus 5. Now, let's do our second perpendicular bisector, and this time we're going to look at the perpendicular bisector of DE. So now when I do that, I'm going to find the midpoint of DE, because that's the first thing we plotted. So now I'm going to look at these coordinates, and I don't want to mess them up. So 3 plus 9 divided by 2 for the x's, 6 plus 0 divided by 2 for the y's, and that will give me 12 over 2, which is 6, and 6 over 2, which is 3. So there we go, there's my midpoint. Now let's find the slope of DE. So y2 minus y1, x2 minus x1, clean this up and we get negative 6 over 6, which is negative 1. So now when I take a negative reciprocal to get my perpendicular slope, I'm going to have positive 1. And now, using my perpendicular slope and my midpoint, I'm going to find the equation of this perpendicular bisector. So y equals 1x plus b. Plug our midpoint in, 3 for y, 6 for x. Let's bring that 6 over, and we get negative 3 for b, which makes our second perpendicular bisector y equals x minus 3. So now, I have my two perpendicular bisectors, which are these two lines right here, and we know the center is the point of intersection. So I need to take these two lines and find the point of intersection algebraically, and you can use substitution here or elimination. I personally, whenever I'm finding the point of intersection with two lines that are both in y equals mx plus b, I'm just going to do substitution. So over here, I know that y is equal to negative x plus 5, and there's a y there, so I'm just going to do a swap like that. So I'm going to write negative x plus 5 instead of y equals x minus 3. And now I'm just going to rearrange to solve for x. So negative x minus x equals negative 3 minus 5. That's negative 2x equals negative 8. We can divide both sides by negative 2. And our x is 4. And now to find our y coordinate, we can plug it into either equation. I'm just going to plug it into my second one. So 4 minus 3. So the y coordinate is 1. And if we look at our sketch, it was rough, but that does kind of appear to be possible, that 4, 1. So therefore, the center is at 4, 1 for this circle. And there it is. We found two perpendicular bisectors, which is knowledge we've already had, and then we did a substitution to find the center, which again is knowledge that we had, but we're just combining our knowledge of perpendicular bisectors and linear systems to find that point of intersection, which is the center. Now, a little extension here, determine the radius of the circle. So we know that the radius is the distance from the center to any point on the circle. So I'm just going to make a little note of that. Distance from center to any point. Now we know what our center is. Our center is 4, 1. We just figured it out. And we technically have 3 potential points right here that we can use. So I'm just going to use point C because that's the first one. So negative 1, 2. And now I'm just going to find the distance between these 2 points using my distance formula. So I can label x1, y1, x2, y2, and now I'm just going to plug it into that distance formula. So x2 minus x1 all squared plus y2 minus y1 all squared. And you could have put your y's first and then your x's afterwards, up to you. But here, negative 1 minus 4 is negative 5, 2 minus 1 is 1. And when you square any number, positive or negative, it will become positive. So negative 5 all squared is 25. 1 squared is 1. So my distance is the square root of 26 units. and that's the exact radius. So maybe I'll erase this and write R for radius. If I want to round it, I can go ahead and do that and plug it into my calculator, and I get approximately 5.1 units. And there it is. Okay, let's go to our next one. A circular room is to have a disco ball installed at the very center. The points -7,4, -4,5, and 0,3 are on the circumference of the room. Where should the disco ball be located? So we want the center of the circle with those 3 points on the circumference. So let's go ahead and plot these points just for the visual. So -7,4, -4,5, and 0,3. And I'm just going to label these A, B, C. You can use any letters you'd like. And now let's connect the dots to create our circle roughly. All right, so you're going to need to pick 2 chords. I'm going to pick AB and BC. And now let's find the perpendicular bisectors and then do a point of intersection. So I want you to pause the video here and try to find those perpendicular bisectors of AB and BC, and then do substitution or elimination to find the center. And once you do that, come back to the video and check your answer. All right, so for the perpendicular bisector of AB, for your midpoint of AB, hopefully you had -11/2, 9/2. For your slope of AB, hopefully you had 1/3, and then the negative reciprocal would be -3. And now we can do our y = mx + b. And yes, our midpoint is a fraction, but that's okay. We can deal with that. And what I will do is put that -3/1 so I don't mess up my multiplication. So -3 times -11 is +33, and 1 times 2 is 2. And now we can bring that 33/2 over. And we'll have 9/2 minus 33/2, which is -24/2, which reduces to a nice y-intercept. So the equation of our first perpendicular bisector is y = -3x minus 12. Now, let's do our next perpendicular bisector of BC. So hopefully for the midpoint of BC, you got -2, 4. For the slope of BC, -1/2, which makes the perpendicular slope +2. And now we can do our y = mx + b. Put 4 in for y, -2 in for x. Simplify the multiplication and bring that -4 over, so that you get 8 for your y-intercept. So there we are. There's our second perpendicular bisector. Now, if you have noticed that you've struggled with finding the perpendicular bisector, I recommend you go back to the perpendicular bisector video and watch that again. Now, if you did get here, now we will be doing our substitution or elimination. I'm going to do elimination, and instead of putting y here, I'm going to put what y is equal to. So I'll write 2x + 8 equals -3x minus 12. And now I'll do my swapping, and I make sure to change my signs when something moves over the equal sign, so that I have 5x equals -20, divide both sides by 5, and x equals -4. Now I'm going to take this x value and I'm just going to plug it into my second perpendicular bisector. It really doesn't matter which one you plug it into, but instead of x I will put -4. And now 2 times -4 is -8, and when we add on 8, we get 0. So there is our point of intersection which is the center of the circle. Therefore, the center is at -4, 0. And there we are. Find two perpendicular bisectors and find the point of intersection to get that center.